In this video, we're going to be furthering our understanding on binomial theorem. We're going to be moving from Pascal's triangle to the use of combination notations for our binomial series. Now, in the Pascal's triangle, we notice this symmetry. It could be around a number like we have here, 4, 1, 4, 1. Or it could just be a direct symmetry like 1, 3, 3, 1. Okay, this symmetry reflects a kind of arrangement that we find in combinations. Okay, now what am I saying in essence? So if you have 5 items, and out of that 5 items you're trying to select, let's say you're selecting 2 items, we were made to know that it is the same as having the same number of items and selecting 3 items. Let me show you. Let's say the 5 items are A, B, C, D, and E. And we're trying to select 2 at a time. Alright? So how many ways? So let's start with A. A and B can go together to give us AB. A and C, AC, A and D, AD, and A and E. That gives AE. So these are the possible combinations we can have with A. So let's go to B. We cannot go back to A because we have AB already. So we just have to proceed with B and C. Then we have B and D, BD. And lastly, B and E, we have BE. Now all the possible partners for B have all been selected. Now let's move on to C. C can go with D, we have CD. And C can go with E, we have CE. That has been settled. Now let's do the same for D. So D only has one partner, so we have DE. If we count this all together, we can see that we have 10 ways. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 ways. So we write that 5 combination 2 equals 10. Remember I said earlier on that if you have 5 items and you're selecting 2 items, it is the same as having the same 5 items selecting 3. So let's use the same letters to explain that. A, B, C, D, and E. So because we are picking 3, not 2, so I'm going to be starting off with 2 letters now. So I have AB. Now I can pitch my AB with C, ABC. I can pitch that with D, A, B, D. I can do that with E. I have A, B, E. Now that has been cleared. Now let's pick A and C again. Now we cannot go back to B obviously because we have ABC already. So we go to ACD. ACD. And then we go on from that to E. So we have ACE. And that has been cleared for AC. So let's do for AD. Unfortunately, AD has just one partner, which is E. So we have E. And that's settled for A. Now let's move on to B. B. I'm picking B and C at a time now. So we have BC. So B and C can go with D. We have BCD. And B and C can go with E to give us BCE. That is cleared. Now we can pick B and D now. Remember? So we have B, D. That can only go with E, unfortunately. So we have B, D here. So that is all. That is how far B can go. Let's go with C now. Now C and D can only go with E. So we have C, D, and E. So that's all, because if you proceed, you won't have any other letter to match it up with. So let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have that 5 combination 3 equals 10. Okay, so we've been able to establish now that 5 combination 2 is equal to 5 combination 3. Remember the definition that I gave earlier on about combination? Okay, that can now be expressed as saying that selecting R items, okay, from N items, that is, N combination R is the same as selecting N minus R items from N items, that is, N combination N minus R. In the combination notation, you can use N, then the big C, then a small r, or you can write this or this. So they literally mean the same thing. Now, by calculation, okay, so let's say you have a problem you are trying to solve, a combination problem you are trying to solve, and you don't want to go through this process of, drawing thousands of arcs and all of that. You can use the combination formula. That is, if you have N combination R, it can be written as N factorial divided by N minus R factorial R factorial. So which means that if you have 5 items and you are selecting 2 items, remember, N is 5 and R is 2. So this becomes 5 factorial divided by 5 minus 2 factorial 2 factorial, and this is equals to 5 factorial divided by 3 factorial 2 factorial. We know what factorial means, right? So it's more like you take 5 times 4 times 3 times 2 times 1. So we have 5 times 4 times 3 factorial divided by 3 factorial times 2 factorial. Now this divides this. So we have 5 multiplied by 4 divided by 2 factorial. 2 factorial is 2 times 1, right? So which is 2. So this 2 divides this 2 times, and that gives 10. So if we do the same for 5 combination 3, we'll be having 5 factorial divided by 5 minus 3 factorial, then 3 factorial, and that's 5 factorial over 2 factorial 3 factorial. From here you can see that they are actually the same, so that's going to be 10. So we can see that 5 combination 2 is equal to 5 combination 3. Now by that reasoning, 5 combination 1 is the same as 5 combination 5 minus 1, which is 5 combination 4. Okay, so I can say that 5 combination 1 equals 5 combination 4. Now we can try some other numbers. Okay, so if you look at 7 combination 1, it is the same as 7 combination 6. If you take 7 combination 2, it is the same as 7 combination 5. And if you take 7 combination 3, that is the same as 7 combination 4. Remember I said something about Pascal's triangle and this. Okay, now in the Pascal triangle, where we have 1, 1, 2, 1 and all of that, we can pick a row and use this as an example. So let's pick this row, which is what we've been dealing with all this while. So we have 1, 5, 5, 10, 10, 5, 1, right? So let's work with that. 1, 5, 10, 10, 5, and 1. Did I get that right? All right, great. Now, in actual sense, okay, this is actually 5 combination 0. This is 5 combination 1. This is 5 combination 2, 5 combination 3, 5 combination 4. This is 5 combination 5 in actual sense. And if you look at the arrangement, actually, you can see that, oh, something is making sense, right? We can see that 5 combination 0 is the same as 5 combination 5. That's settled. And we can also see that 5 combination 1 is the same as 5 combination 4. Also, we can see that 5 combination 2 equals 5 combination 3. So we can use this idea for our binomial expansion going forward. Now let's use that understanding to solve this problem. So we want to expand x plus y to the power of 5. So this power tells us that, okay, we are dealing with 0 to 5 from that point of view. That is, we have 5 combination 0, 5 combination 1, 5 combination 2, 5 combination 3, 5 combination 4, and 5 combination 5. And by symmetry, 5 combination 0 is the same as 5 combination 5, while 5 combination 1 is equal to 5 combination 4, and lastly 5 combination 2 is equal to 5 combination 3. Now let's find the solutions to this first. Right. So 5 combination 0 or 5 combination 5. Let me pick the one with the bigger number. Right. Remember the formula for combination says if you have n, combination r is going to be equal to n factorial over n minus r factorial, r factorial. So 5 combination 5 is going to be 5 factorial divided by 5 minus 5 factorial, 5 factorial from that point of view. And this is equal to 5 factorial divided by, this is 0. 0 factorial is 1 and times 5 factorial. So we have that at the top and at the bottom, so that goes to 1. So which means 5 combination 0 and 5 combination 5 equals 1. Now if you do the same for 5 combination 1 equals 5 combination 4, you have 5 as an answer. So if you apply the same rule for 5 combination 4, you can pick 5 combination 1. It doesn't matter. You're going to get the same answer. We're going to have 5 factorial divided by 5 minus 4 factorial, 4 factorial. Now 5 factorial, let's retain that. 5 minus 4 factorial is 1 factorial, and this is 4 factorial. Now let's simplify this. So 5 factorial is 5 times 4 factorial divided by 1 factorial is 1, right? Times 4 factorial, which is the 4 factorial. So 4 factorial divides 4 factorial, then we have 5. Now lastly, 5 combination 2 equals, so if you use the same process, 5 factorial, 5 minus 3 factorial, 3 factorial, this is going to be 10. So this is 5. So we have 1, 5, and 10. Now let's go back to our expansion. X plus y to the power of 5 is going to be equal to, starting with 0, it's going to be 5 combination 0, x raised to the power 5 plus, okay, 5 combination 1, x raised to the power of 4, because the power keeps reducing while the power of y begins to grow. Y raised to the power 1 plus 5 combination 2, x to the power of 3, y to the power of 2 plus 5 combination 3, x to the power of 4, x to the power of 2, y to the power of 3 plus 5 combination 4, x, y to the power of 4, and lastly 5 combination 5, y to the power of 5, because the next is supposed to be x to the power of 0, which is 1. Now we'll solve this, right? So we have x to the power of 5. 5 combination 1 is 5. So we have 5 x to the power of 4 y plus 5 combination 2 is 10 x cubed y squared plus 10 again x squared y cubed plus 5xy to the power of 4 plus y to the power of 5. Okay, so henceforth I'm going to be sticking with this notation rather than using this. So you can use any of the two, right? So but whichever one you want to choose, please stick with it, right? So henceforth I'm going to be sticking with the parentheses form. Now let's pick one more example. So let's say you have 2 plus x raised to the power of 7. So the first thing is to write out all the possible combinations that you can have. So basically 7 combination 0 is going to be equal to 7 combination 7. Okay, and 7 combination 1 is going to be equal to 7 combination 6. 7 combination 2 is going to be the same as 7 combination 5, while 7 combination 3 is going to be the same as 7 combination 4. That's all, right? Now 7 combination 0, this is going to be equal to, it's going to be equal to 1 if you do your math. So this is 1. Now 7 combination 1 equals 7 combination 6, right? So let me tilt towards the bigger number. So that's 7 factorial over 7 minus 6 factorial, which is 1 factorial, 6 factorial. So this is 7 times 6 factorial over 6 factorial. So this divides this, so we have 7 for this. Now the same goes with this, all right? So let me pick the smaller number this time. 7 factorial over 7 minus 2 factorial, 2 factorial, and that is 7 factorial over, this is a 5 factorial, 2 factorial. So when you solve this, you have 7 times 6 times 5 factorial over 5 factorial 2 factorial. So 5 factorial divides this, right? And we have 2 factorial is 2, that is 2 times 1. So divide this, we have 3, and this goes, so this becomes 21. Lastly, if you do the process for this, you have 35. Now let's go back to our expansion. So by expansion, I'm supposed to write that 7 combination 0, 2 raised to the power of 7, right, plus 7 combination 1, 2 raised to the power of 6, x, plus 7 combination 2, 2 raised to the power of 5, x squared, plus 7 combination 3, 2 raised to the power of 4, x now goes to the power of 3, plus 7 combination 4, 2 raised to the power of 3, and x goes to the power of 4, plus 7 combination 5, 2 raised to the power of 2, now x goes to the power of 5, plus 7 combination 6, 2 raised to the power of 1, then x to the power of 6, plus 7 combination 7, then we have x to the power of 7. So based on the results that we have obtained, 1, 7, 21, 35. Now this becomes 1 times 2 to the power of 7. We have 2 to the power of 7. Plus 7 combination 1 is 7. So we do 7 times 2 to the power of 6 x. Plus 7 combination 2 is 21. So we do 21 times 2 raised to the power of 5 x squared, plus 7 combination 3 is 35, times 2 raised to the power of 4 x to the power of 3, plus combination 4 is still 35, so 35 times 2 to the power of 3 x to the power of 4, plus 7 combination 5 is 21, right? Okay, so we do 21 times 4 x to the power of 5 plus 7 combination 6, that is 7. So 7 times 2 x to the power of 6 plus x to the power of 7. So when you go on with this expansion, 2 to the power of 7 is 128. So we have 128 plus, now 7 multiplies 64, right? So that gives 448x plus 21 multiplies 32. I beg your pardon. So that gives 672 x squared. Now this plus 35 multiplies 16, right? So this is going to be 560 x to the power of 3 plus, if you go on, you have 35 multiplied by 8, so that is 280 x to the power of 4 plus 21 times 4, that is 84 x to the power of 5, and 7 multiplied by 2 gives 14 x to the power of 6. Lastly, we have x to the power of 7. So that is the expansion, and that's how to use the combination, right, for your expansion.